So, properties of exponents, you should have seen this in Algebra 1. You don't have to have the names memorized. So, for these names, there are 7 of them. You do not need to memorize, so don't memorize the names. Those are just fancy ways of telling you all of these. So, for the first one, product of powers, essentially what that means is if you have two numbers that are the same, then you can add the exponents together. So if you're multiplying, then you would add the exponents. So 3 squared times 3 to the 5th. Since both of these have the same base, you would add the exponents together. If you're raising a power to a power, that is when you multiply. So 2 cubed squared, you would multiply 3 times 2. If you have two terms that are in parentheses and an exponent on the outside, you would distribute that exponent to A and distribute it to B. So for instance, we have 4 times 3 cubed. You would distribute the cube to the 4 and to the 3. This usually works better when you have, so if this were x and y, it would be like x cubed, y cubed, because you could really simplify the 4 times 3 to be 12. If you have a negative exponent, so anything that is negative, then you would want to bring that to the opposite side. So if it's on the numerator and it's negative, then it would become a positive exponent on the denominator. So if you have 5 raised to the negative 2 power, it's the same as saying 1 over 5 squared. So here the squared becomes positive when it's on the denominator. If you had 1 over 5 to the negative 2, then it would jump back up to the numerator and it would equal 5 squared. So basically if you have a negative exponent, you're going to switch it from numerator to denominator, denominator up to numerator. And we'll see some examples. Really the best way to learn about these properties is to just have practice. The next one is the zero exponent. So anything that is raised to the 0 power, it does not matter what it is, anything is always going to be equal to 1. So you could have 5,280,000 to the 0 power and it's still going to be 1. Quotient of powers, so if you have the same term on the top and the bottom, you're just going to reduce or simplify your exponents. So if you have 3 to the 5th over 3 squared, it is like saying 5 minus 2 or 3 cubed, 3 to the 3rd power. So you're just taking 5 minus 2. Same with power of quotient. So power of product, power of quotient, those kind of go together. You distribute, if you have A over B, you distribute the exponent to the top and to the bottom. So again, if we had x over y to the 4th power, it would be the same thing as saying x to the 4th over y to the 4th. So you just distribute your exponent. So we're going to do a few examples. You can follow along in your notes. And really doing examples is going to be the best way to help. So here we have x to the negative 4th, x to the 6th, x to the 7th. And all of these are multiplied together. So since they are multiplied, then I can take my exponents. So I have negative 4, 6, and 7. And I can add those together. So I'm going to take negative 4 plus 6 plus 7. And you end up getting a positive minus 4, a positive 9. So your final answer would just be x to the 9th power. This should be a 9. So remember, when they're just multiplied together, you're not raising a power to a power. You just add the exponents. So x to the 9th. Next example, we have two things in parentheses. They're multiplied by multiplication. I'm multiplying them together. So I'm going to combine my like terms. I'm going to start with the constant. So I have a 2 times a 10, which gives me 20. Now I'm going to combine my x values, or my x's. So x to the 5th and x to, since there's no exponent there, it's like saying x to the 1st power. So if I have 5 and 1, they're just multiplied together. So I will add the exponents. I would get x to the 6th power. Then I'm going to combine my y's. So y to the 1st, y to the 5th. So y to the 6th power. And then lastly, I have z cubed, z to the 10th. So 10 plus 3, z to the 13th power. And this would be as simple as you could have it. The next one, we have a power to a power. So we have x to the 7th squared. So this is where I would take 7 times 2. So my answer would be x to the 7 times 2, which would just be x to the 14th power. And then I am done. So remember, when you have a power to a power, that is when you multiply. But if they're all on the same horizontal line, like x to the 7th times x to the 5th, that is when you add. Okay, now I have this exponent that's outside the parentheses. So I'm going to need to distribute this cubed to every single term. So I'm going to distribute 4 cubed, and 4 cubed is equal to 64. So I'm going to write 64 down here. Then I have a squared. I'm going to distribute that. So since it is a power to a power, a times 2 times 3. So I get a to the 6th power. Distribute the 3 to the b. So b times 3 times 3. So that would be b to the 9th power. C cubed. And d cubed. So every single term gets the cubed. Since c and d are just raised to the 1st power, it's like 1 times 3, and d 1 times 3. Okay, now I have a negative exponent. So when you have a negative exponent, remember that you need to move to the denominator. So when you move it to the denominator, it just becomes 1 over r to the 4th. So when you move it to the bottom, move it to the denominator, it becomes a positive exponent. So anytime you have a negative, just switch it, and it becomes a positive exponent. Number 6, same thing. Here's a negative exponent, so I'm going to move it to the denominator. And I can write this as 3r over s. S to the 1st power. You don't have to write the 1st power. Just going to erase that. You can just leave it like this. So when I move s to the denominator, it becomes a positive exponent. So exponent becomes positive. Okay, here what I like to do, so I have exponents negative here, 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 and that is it. What I like to do is I like to go ahead and switch first, meaning I like to switch my exponents to become positive, so I flip, and then I simplify. So if I were to move, or if I were to flip these, my new numerator, if this would become squared on the bottom and x to the first on top, I would have 3x to the first y. So this x to the first moves up to the top. Then this x squared, that is right here, jumps to the bottom. So x squared on bottom, y to the fifth on bottom, and then this z now jumps to the bottom, and I have z to the first and z to the negative 3. I'm going to combine those to become z to the fourth on bottom. So 1 plus 3, because I'm moving it down. So now I have everything with a positive exponent. The next step is I want to now simplify. So simplify, all that means is I want to reduce my x's and my y's. So I have x to the first over x squared, 1 divided by 2. So I'm going to rewrite this as 3x squared. The number is bigger on the bottom, so that leaves me with just an x on the bottom. Then I have y over y to the fifth. So my exponent is larger on the bottom, so 5 minus 1 would become y to the fourth. And then there are no z's, so I leave this as z to the fourth. So this would be my final answer. Guess you could put 3 in the middle. It's going to bother me. I'm going to rewrite that, put 3 in the center. There we go. Like this. Okay, next example. I have a 0 exponent, so none of this stuff matters. It's all to the 0 exponent, so it equals 1. And then you're done. So those are really easy. Hope you want to get one of those on a test. Here we have this negative exponent, a power to a power. So I'm going to distribute this negative 3 here to the top and to the bottom. So this would become r to the negative 2 times a negative 3, power to a power, over s cubed times a negative 3. Now I'm going to multiply, so multiply these, and I get r to the positive 6th power over s to the negative 9th. So now I have a negative 9 on the bottom, negative exponent. I want it to become positive, so that means that I need to move it up to the top. So my final answer would be r to the 6th power, s to the positive 9th. So this guy comes up to the numerator and becomes positive. So move him to the numerator. Same rule applies if I have a negative on top, I move it to the denominator. If you have a negative on bottom, you move it up to the numerator to become positive. Okay, one last example. So here I'm going to simplify the like terms. So I have a 16 and a 2 that go together. 16 over 2 can reduce to a positive 8. There are no m's that line up together. So m is kind of by itself. So I'm going to leave that as m to the 4th power. Then I have n's that go together. So n to the negative 5, n to the negative 5. Those actually end up just canceling each other. So my final answer would just be 8m to the 4th power.